Well, hello everybody. Hey, sorry you missed class, or sorry that I missed class, whichever occurred today. If you're here and if I were there, I would answer any questions over section 1-6 that you had. I would also answer any questions over the practice quiz that you had, and I would let you ace the 1.4 through 1.6 quiz. And you're very right, we don't call it a quiz, the grade we're raising opportunity. But what I need to cover with you today is what's called the bell curve, or also just called the normal distribution or normal curve. It's really a phenomenon in the real world of just here's some facts that I'll show you as we go along. You will make a note card today of the bell curve and some percents used within the bell curve. So here's where I need to go with you. The normal distribution, called the bell curve, it's just a function of the mean and the standard deviation. What I'll do today is I'll show you an application of that standard deviation that we found last time. Remember the standard deviation either look like that or look like that. Today we're going to apply that standard deviation into a set of data just so you can see some facts and how they work. The reason it's called a bell curve, guys, most of the information is in the middle. You'll have some information out to both sides, but as you really look at it, you get a curve that looks something like that. So let me go on to here. What kind of items fall into what we call the bell curve? If you've ever taken a standardized test in grade school and middle school, taken the ACT, the SAT, anything like that, you are a member of the bell curve. If you have an IQ, you are a member of the bell curve. If you have a height or a weight, or use light bulbs in your household, you are a member of the bell curve family. I'm just going to show you some facts here as we go. But what I need you to do is you can pause this or come back later, but what I need you to do on your note card or on a piece of paper that we can transfer to a note card in the very near future, come up with a piece of paper, the note card, and just label it facts about the bell or normal curve. And guys, what you'll do on your note card is you'll just have some base, and you'll have a curve that looks something like this, kind of like I have right here. Now I'm going to give you some facts about the bell curve, and then I'm going to show you some applications of the bell curve, just so that you can understand it. These are not going to be on your class notes, so just kind of hang with me and you'll understand. Whenever you have a bell curve, in the middle will always be your average. Technically, it's also the median. You have so many pieces of data that your mean and your median represent the same thing. Now, as you go to the right, you can be 1 standard deviation above the average, or 2, or 3. We never go above 3, and you'll see why here in just a second with the percents. Same thing to the left. You can be 1 deviation below, 1 deviation, 2 deviations, 3 deviations below. So guys, if you would, on your bell curve, draw this, draw that down the middle, average, come over some, and draw those 3, 2, and 1 deviations away. Now here's some facts. If you know your average and your standard deviation, and you add that to your mean and subtract that from the mean, 68% of your data will lie between that. That is just a fact. It also means this then. 34% will lie above the mean for 1 deviation, and 34% will lie below. So these are just some facts. These percents that I'm giving you, they will not change. These are just some facts. Whenever you look at 2 deviations from the mean, meaning 2 deviations above, so you've added the standard deviation twice, and 2 deviations below. 95% of the population, of the test scores, of the light bulbs, of the heights, will lie within 2 deviations. Like I said, here in a little bit I'll show you an example. Now guys, what I'm going to do now is I'm going to go 95 minus 68, and I'm going to get 27. Half of 27 is 13.5. That means 13.5% of all the data will lie from 1 to 2 deviations above, and 13.5% of all the data will lie between 1 and 2 deviations below. So all those percents will go on your note card. Now, within 3 deviations, 99% of all the data will lie. What's that mean for you? I'm going to take 99 minus 95, which that gives me 4. What that means is that 2% of your data will be 2 to 3 deviations above, and 2% will lie below. Now notice we've used 99%. That leaves a percent left over. So that means above 3 deviations will be 0.5%, and below 3 deviations will be 0.5%. So guys, that's what your note card should look like. Like I said, if you don't have a note card, get it down on a piece of paper. We'll give you a note card, and then get it transferred to the note card. But what you would need is this bell curve, this line drawn, and then these percents, the 34, the 13.5, the 2, and the 0.5. And then if you'd like, right below it, do like I did there. 68% of the data, 95% of the data, and 99% of the data. Now, if you need, feel free to pause the video and write that down. But I'm going to go on. I'd like to show you an example of the bell curve. Now, here's just some facts. The average height of men in the United States is 5 foot 10 inches. That's just a fact. The standard deviation is approximately 3 inches. Really, it's like 2.97, but I rounded it up for simplicity's sake. I'm going to shoot some facts at you about heights of males in the United States. What I'm going to do is this. At the average, I'm going to put 5 foot 10 inches. Now, I'm going to add 3 inches. So I'm going to add 1 deviation. So 5 foot 10 plus 3 inches brings me to 6 foot 1 inch. I'm going to do that again. Add 3 inches again, I'm going to be at 6 foot 4 inches. And then do it again, I'm going to be at 6 foot 7 inches. Now let's go the other way. I'm going to subtract 3 inches. So I'm going to be 5 foot 7 inches. Subtract 3 inches, I'm going to be 5 foot 4. And I'm going to be 5 foot 1. Wherever I was. Let me get back to my starting place. Okay, I should be back now. So there's the heights associated with our bell curve. Now come into it, if you would, and fill in the percents on your note card. So remember, there's a 34% right there. And there's a 34% right there. And then I'm just going to shoot some facts at you. There's a 13.5% there and there. There's a 2% there and there. And there's a 0.5% way out there. Now guys, here comes some facts. They're just facts. 34% of all men in the United States are between 5 foot 10 and 6 foot 1. That's just a fact. 68% of all men in the United States is between 5 foot 7 and 6 foot 1. Here comes another fact for you. If I add 34 and 13.5, to get 47.5%, here comes another fact for you. 47.5% of all men in the United States are between 5'10" and 6'4". These are just facts. There's so much data in here that if somebody's born super short, super tall, it really doesn't affect anything. Okay? Just a couple of more facts for you. 2% of all men in the United States are between 6'4" and 6'7". It means also then that only 0.5% of all men born in the United States are above 6'7". So you kind of see how the bell curve works. I could go the other side also. 13.5% of all men in the United States are between 5'4" and 5'7". So just facts about the bell curve. Okay. Here's another one that's not on your class examples, but we're going to fly through it here. It says a standardized test has an average of 50 and a standard deviation of 4. Find the probability of test scores between 42 and 48. Since I know the average is 50, I'm going to put 50 right there. The standard deviation is 4. So I'm going to add 4, add 4, add 4, subtract 4, subtract 4, subtract 4. Let's put in some percents. 34, 13.5, 2, and 0.5. Guys, those percents do not change based on our problem. They're always the same. Now let's go answer the question. Find the probability of test scores between a 42 and a 58. I need to add all of those up, or it's 2 above and 2 below. I'm going to get 68%. No, I'm not. I'm going to get 95%. So that's how the bell curve works. These percents stay the same. These numbers can change for you. Now, if you would come over to your class examples real fast. We've touched on this before. This is your example number 1. Here's a set of data. 14, 15, 12, 11, 13, 13 appear to be positively skewed, negatively skewed, or normally distributed. Here's what we'd have to do to tell. Down here, guys, I'm going to do a dot plot. So I put 11, 12, 13, 14, and 15. I'm going to go count the number 11s that I have. When I come up here, it looks like I have 1 11. So I'm going to put 1 dot. If you go count the number 12s that you have, it looks like I have 1 2. So I'm going to put on 12s, I have 2. If you go count the number of 13s that I have, 1 2 3. Go count the number of 14s. 1, 2, 3, 4. So let me go up 4 dots. When I count the number of 15s, looks like 1, 2, 3 of them. Now here's how to tell if it's positively skewed, negatively skewed, or normally distributed. If you connect these dots, where's the tail at? Well, if you look at it, this thing has a left tail. Well, but they want to know if it's positively, negatively, or normally. Well, since the tail's to the left, this thing is going to be called negatively skewed, because to the left is our negative numbers. So to tell if it is, you look at it and see where the most data is. We've got some more of those coming up here in just a second. But all I did is I did a little dot plot to see where it looks like the most is. Come over to your example 2 if you would. It says the reaction time for a hand-eye coordination test administered to 1,800 teenagers are normally distributed with a mean of 0.35 and a standard deviation of 0.05. About how many teens had reaction times between 0.25 and 0.45? Now be careful, guys. Sometimes it's going to ask for a percent. Other times it's going to say how many. So I need a number less than 1,800. So to attack that, here's what we're going to do. Sketch yourself a bell curve, if you would. Right down the middle, put the average, which the average was 0.35. Now the standard deviation was 0.05. So I'm going to add 0.05 and get 0.40. Add 0.05 and get 0.45. Add 0.05 and get 0.50. And then now let's do it the other way. Subtract 0.50. Subtract 0.50. Subtract 0.50. Now let's also come in and quickly put those percents in there. I figure, guys, the more you list those percents, they're going to become common knowledge to you. You really won't even need your note card. You got it there just in case. So here goes our part A finally. About how many teens had a reaction time between 0.25 and 0.45. I need to add those percents up. So I'm going to add up the 13.5, 34, 34, 13.5, and you're going to get 95%. Well, it means 95% of the 1,800 teenagers had reaction times between 0.25 and 0.45. If we multiply that out, we're going to get approximately 1,710 teenagers. Now notice there, though, it said how many. When you come to part B, though, it says what's the probability that a teenager selected at random had a reaction time of greater than 0.40. So I need to go from here on. So I need that 13.5, that 2, and that 0.5. Add those up, 16%. So that's how the bell curve works. Now, I'm going to go ahead and just kind of start your homework with you a little bit. Video-wise, I'm only in here for 18 minutes already, so I've covered the lesson, but if you want me to get a jump on your homework with you, just hang on. Here's your number 1. It says sketch a positively skewed graph. That means it needs to be right-tailed. So have yourself some graph and just make sure it's right-tailed. So I could go anything like that. And then I got it whipped. That's one example of many. Here's your number 2. Compare the means and the standard deviations of the graphs below. Well, if you look at it, the means are the same. Now, remember last time when we talked about standard deviation? The least standard deviation will have more in the middle. The least standard deviation will have the least in the middle. So I know that the standard deviation of this one is the least. So I'm going to say graph 1 has the least standard deviation. This one has the least amount in the middle. Graph 3 has the largest. So there's your number 2. And if I ever get going too fast on a video, just hit pause. Here's your number 3. What percent of a set of normally distributed data is more than 3 standard deviations above the mean? So look on your note card, go to 3 standard deviations above, and see what percent's tied for that. So that's going to be right at 0.5%. Here's your number 4. The table at the right shows female mathematics SAT scores in 2000. Determine whether the data appears to be positively skewed, negatively skewed, or normally distributed. We could do a dot plot like we did earlier, but I don't want to draw 33 dots. So just kind of look at your data. It really looks like I have close to the same amount on the ends, close to the next amount on the ends, and it looks like I got about most of them in the middle. Well, if the most of them's in the middle, that's going to be normally distributed. I'll hit the next couple with you, then I'll quit. Here's your number 5 through 7. It says, Miss Jones gave a test in her trigonometry class. The scores were normally distributed with a mean of 85 and a standard deviation of 3. Let's pause there for 1 second. Let's come in, draw the bell curve. Let's put the average of 85 right there. Let's go up 3, so I'm at an 88. Up 3, I'm at a 91. Up 3, I'm at a 94. Down 3, I'm at a 82. Down 3 is 79. Down 3 is 76. Come into here and let's put your percents real fast. 34s, 13.5s, 2s, and 0.5s. Now, whatever questions show up, they should be easy to answer based off this. Number 5, what percent would you expect to score between an 82 and an 88? Add up those percents right there. So I'm going to have approximately 68%. Might be 67.9, might be 68.1, but we're right at 68%. What percent would you expect to score between an 88 and 91? Well, if you look between there, we're going to have about 13.5%. Now, my number 7, what's the probability that a student chosen at random scored between a 79 and a 91? So we're going to go from a 79 to a 91. Add up all of those percents. Or notice that I'm 2 deviations away. 2 deviations is 95%. So guys, that gives you a great jump on your homework. There's more there, but I'll kind of quit for now. If you have any questions, buzz in and we'll get you straightened out. Good luck to you.